Hello everyone, welcome back to the screw gauge series, and this is the fifth part. And in this part we will solve few questions from previous JEE and NEET papers. Let us see the first question. A screw gauge with a pitch of 0.5 mm and a circular scale with 50 divisions is used to measure the thickness of a thin sheet of aluminum. Before starting the measurement, so it is found that when the two jaws of the screw gauge are brought in contact, the 45th division coincides with the main scale line and that the zero of the main scale is barely visible. What is the thickness of the sheet? If the main scale reading is 0.5 mm and the 25th division coincides with the main scale line. So in the first line, it is given that the pitch of the screw gauge is 0.5 mm and the circular scale division, that is 50. So by using these two values, we can find out the least count, because least count of a screw gauge is defined as pitch of the screw gauge, that is 0.5 given here, divided by the number of head scale divisions or circular scale divisions, that is 50. So that value gives 0.01 millimeter. This is the least count of the screw gauge. In the second step, before starting the measurement, it is found that when the two jaws of the screw gauge are brought in contact, the 45th division coincides with the main scale and that the zero of the main scale is barely visible. Okay, the part that is the zero error of a screw gauge is the most important part, where most of the students they get confused. Okay, so in the first question itself, we come across this kind of situation. So it will be very useful because we'll see the detailed explanation related to this topic. So in the case of a screw gauge, okay, when both the anvil and the spindle they are in contact with each other, and if the zero of the circular scale or head scale is coinciding exactly with the reference line or the index line on the main scale, then the given screw gauge is said to have no zero error. Okay, so in that case, whatever the measurement you take, that will be accurate. So no need of any correction. Now we go for the positive zero error. So in the case of a positive zero error, okay, here if you close the screw gauge completely, that is both the anvil and spindle, okay, they come in contact with each other. So in that case, instead of zero, some other value is coinciding and the zero is below the reference line. Okay. And if you see the main scale, okay, the zero of the main scale is visible, completely visible, and the edge of the thimble is on the right of the zero line. So here, this situation can be compared with the measuring tape that is taken as the example while explaining the concept of zero error. So if the zero of the measuring tape is shifted forward, so in that case, whatever the measurement you take, so it will have some extra value. So here, the measurement is not starting from zero, it is starting somewhere else, where the edge of the thimble is exactly coinciding. So that means the zero of the main scale, it is shifted forward. Therefore, this situation is said to have the positive zero error. That is, the screw gauge is said to have a positive zero error. Otherwise, if you just look at the circular scale only, and if you take the circular scale in the horizontal manner, so in that case, if you just look at the zero of the circular scale, it is coming to the 10th division. That means the zero of the circular scale, it is also shifted forward. So if you take the circular scale horizontally, you can see the same situation. Okay, both the zero of the main scale as well as the zero of the circular scale, both are shifted forward. In that way, you can understand the zero error of the screw gauge. Okay, now we go for the other situation, negative zero error. In this case, okay, when the anvil and spindle, okay, both are in contact with each other, the edge of the thimble, okay, it is fully covering the zero line of the main scale. Actually, the measurement, okay, it starts with the zero of the main scale, and if the screw gauge is not having any zero error, the edge of the thimble will also be coinciding with the zero of the main scale. So here, the edge of the thimble, it is shifted backward. And if you also look at the zero of the circular scale, in this case, okay, you can see that, okay, the zero is not coinciding with the reference line, and the zero is, okay, coming to the 95. Okay, that means if you take the same circular scale in the horizontal pattern, that just you rotate the screw gauge, and if you take the same circular scale in the horizontal pattern, you can see that the zero is shifted backward, okay, to the 95. Therefore, in both the cases, whether you take the main scale or the circular scale, in both the cases, the 0 is shifted backward. Okay, therefore, with the given screw gauge is said to have a negative 0 error. Okay, here the same thing you can understand. So when the screw gauge, okay, that is, it is completely closed, that means both the jaws are in contact with each other. So 45th division is coinciding, that is one thing. And the other thing is, the 0 of the main scale is barely visible. Therefore, the given screw gauge in the problem is having a negative 0 error. Okay, so in that case, the calculation of the 0 error, okay, the given screw gauge, so we note down the situation, the given screw gauge, okay, the given screw gauge, okay, it is having negative 0 error. Okay, the given screw gauge, it is having negative 0 error. So already we have calculated the least count, that is least count is equal to 0.01 millimeter. Okay, now we calculate the negative 0 error, that is equal to, so 45th division is coinciding. So we know that in the case of a negative 0 error, 45th division means we should not take the number 45 directly. So 45th means the total number of divisions are 50. So therefore it is 5 divisions below. Okay, the 0 of the circular scale is shifted 5 divisions below to the reference line. Okay, therefore, okay, it will be 50 minus 45. That gives the 5 divisions. Okay, otherwise if you have the clear idea, you can take directly 5. Those who are having the knowledge of only the formula, they can use n minus n, that is capital N is the total number of circular scale divisions, and small n is the line of the circular scale that is coinciding with the reference line. So into the least count. This gives a minus of 50 minus 45, that is 5, into the least count, that is 0.01. That will be 0.05 millimeter. Okay, now we go for the calculation of the total reading. So for that, we have to look at the last sentence. In the last sentence, it is given that, okay, the main scale reading is 0.5 and the 25th division, that is HCD, is 25. So we go for the total reading. Total reading, that is equal to MSR, a main scale reading, plus HCD, head scale coinciding division, into the least count. So MSR is 0.5. So next one, HCD into LC. So here HCD is 25 into LC, that is 0.01. So therefore 0.5 plus 0.25. So that is equal to 0.75 millimeter. Now we go for the corrected reading. So I call it as CR. Corrected reading is equal to 0.75. So here it is negative 0 error. So minus 0.05. Therefore, the correction will be positive 0.05. Therefore, it is 0.80 millimeter. So now we look at the options. So 0.80 millimeter is the correction. That is the second option is the correct option. So now we go for the next question. A screw gauge has a pitch of 0.5 mm and 50 divisions on the circular scale. If the circular scale reads 36 divisions and the main scale reads 4.5 mm, find the diameter of the wire and assume, okay, 0 error of the given screw gauge is 0. That means there is no 0 error, no need of correction for the final reading. Now, if you look at the first line, okay, the pitch is given, that is 0.5. The number of circular scale divisions or the head scale division, that is 50. So by using these two values, we can calculate the least count of the screw gauge. That is, least count is equal to pitch by number of head scale divisions. That is 0.5 divided by 50. That gives 0.01 millimeter. Now the second line, okay, it says, okay, it gives the readings related to the diameter of the wire. Okay, the main scale reads 4.5 mm. This is the main scale reading, that is MSR. And 36 division of the circular scale is coinciding with the reference line. Therefore, this is, okay, this is HCD. So therefore, we go for the total reading calculation. That is, total reading is equal to the main scale reading plus the head scale reading. So head scale reading is calculated by taking the multiplication of head scale coinciding division with the least count. So we substitute the values, that is MSR is 4.5 plus HCD is 36 into the least count, that is 0.01 millimeter. So on simplification, 4.5 plus 0.36 and finally 4.86 millimeter is the diameter of the wire. So now we check the options. 4.86, that is the C. The C is the correct option. The next question, a screw gauge has a pitch of 1 mm and 100 divisions on the circular scale. So when nothing is put between the jaws, the zero of the circular scale is 5 divisions below the main scale. While measuring the diameter of a wire, the main scale reads 2 mm and the circular scale reads 45 divisions. What is the diameter of the wire? Again, the first sentence, the pitch of the screw gauge is given, that is the distance moved by the spindle in one complete rotation, and there are 100 divisions on the circular scale. So therefore, we can calculate the least count of the screw gauge. That is least count, it is given by pitch divided by the number of circular scale divisions. So that is 1 mm divided by the number of the circular scale division, that is 100. Okay, that gives 0.01 millimeter. And now in the second sentence, okay, when nothing is put between the jaws, that means when the jaws are completely closed or they are in contact with each other, the zero of the circular scale is 5 divisions below. Okay, that means the fifth line of the circular scale is coinciding with the reference line. So in this case, okay, the zero of the circular scale is shifted above or shifted forward to the fifth division. Okay, therefore, the screw gauge is said to have a positive zero error. So for calculating the positive zero error, so we have HCD, okay, that is 5. Okay, therefore, the positive, okay, zero error, that is equal to HCD into LC or N into LC we say. Okay, that is 5 into the least count 0.01, that is 0.05 millimeter. This is the positive zero error. So since it is positive, we put plus for the 0.05. Now we go for the calculation of the diameter. So for the calculation of the diameter, the readings, okay, MSR is 2 mm. Okay, this is the MSR. And the HCD is 45. Okay, this value is HCD. Okay, therefore, the total reading, okay, for calculating the diameter, that is total reading TR is equal to MSR 2 mm plus HCD is 45 into the least count 0.01. Okay, this gives 2 plus 0.45, okay, that is 2.45 millimeter. Now we have to go for the correction, okay, since the screw gauge is having a positive zero error. Okay, therefore, the corrected reading, that is CR, okay, that is equal to 2.45 minus 0.05, because the correction should be negative when the error is positive. Okay, this gives 2.40 millimeter. Now we check the options, that is the B. So B is the correct option for this question. Next question. A screw gauge has a zero error of minus 0.03 millimeter. Now its pitch is 1 mm and there are 100 divisions on its circular scale. When measuring a wire, the main scale shows 5 mm and the circular scale shows 56 divisions. So what is the corrected diameter of the wire? Here the zero error is given directly. That is zero error, that is equal to minus 0.03 millimeter. And pitch is given, that is 1 mm and there are 100 divisions on the circular scale. Therefore, we can calculate the least count, that is equal to pitch by the number of circular scale divisions, that is 1 mm divided by 100, That gives 0.01 millimeter. And when measuring a wire, the main scale, it shows 5 mm, that is MSR is 5 mm. So this is MSR. And HCD for this reading is 56. So therefore, the total reading we calculate, that is MSR 5 mm plus HCD is 56 into the least count 0.01. This gives 5 plus 0.56, that is 5.56. Now we have to correct this reading. Therefore, the corrected reading CR is equal to 5.56 plus 0.03, because the correction is positive. Therefore, the final answer is 5.59 millimeter. Now, if you look at the options, the option C is the correct one, 5.59 mm. The next question, a screw gauge has 100 circular divisions and a pitch of 0.5 mm. If the screw rotates 4 full turns, so what is the total distance moved? So here the pitch is given, that is 0.5 mm. So we know the definition of the pitch, that is the distance moved by the spindle for one complete rotation of the head scale. So here the value is 0.5 for one rotation. For one rotation, okay, the distance moved by the tip of the spindle, okay, that is 0.5 mm. That is the pitch. So now the question is, so what is the total distance moved, okay, for 4 complete rotations or 4 full turns? That is, for 4 full turns, okay, for 4 turns, okay, what we get? 4 into 0.5 millimeter, okay, that gives 2 millimeter. So therefore, the B, the option B is the correct answer, 2 millimeter. A screw gauge with a pitch of 1 millimeter and 100 divisions on the circular scale is used to measure the radius of a wire. The main scale reads 2.5 mm and the circular scale reads 75 divisions. So zero error is plus 0.02 millimeter. So what is the correct radius? So here in the first sentence, the pitch is given, that is 1 millimeter, and the number of circular scale divisions, that is 100. Therefore, we can calculate the least count, that is pitch 1 mm divided by the number of circular scale division, that is 100. That gives 0.01 millimeter. Now, in the second step, so the main scale reads 2.5 mm and the circular scale reads 75 divisions. That means it is not measuring directly the radius, okay, it measures the diameter. So for diameter, okay, just say D, that is equal to the total reading, TR, that is equal to 2.5, that is the MSR. Okay, so here 2.5 is MSR and 75, okay, this is HCD. So therefore 2.5 plus 75 into the least count 0.01 millimeter. So that gives 2.5 plus 0.75, okay, that will give 3.25 millimeter. So this is the total reading. Now the given screw gauge, it has a zero error, that is zero error is plus 0.02 millimeter. Okay, so this is positive. Therefore, the corrected reading, okay, we need to do the correction for the final reading, that is 3.25 minus, the correction is negative since the zero error is positive, minus 0.02, okay, that gives 3.23 millimeter. So this is the diameter. So now we have to go for the radius, that is radius is equal to diameter divided by 2, that is 3.23 divided by 2. So this gives 1.615 millimeter. From the given options, D is the correct option. So we go for the next question. The next question, A screw gauge has 100 divisions on its circular scale and the pitch is 1 mm. The circular scale shows 60 divisions and the main scale shows 2 mm. If there is a negative zero error of 0.04 millimeter, find the diameter. So here the given screw gauge, it has 100 divisions on the circular scale and 1 mm is its pitch. Therefore the least count, that is 0.01 millimeter. And while measuring the diameter of a wire, okay, the 2 mm is the MSR, that is main scale reading, and 60 is the head scale coinciding division, that is HCD. And the screw gauge, it also has a negative zero error, that is 0.04, that is minus 0.04. Now we go for the total reading calculation, that is total reading is equal to MSR, that is 2, plus HCD, that is 60 into 0.01. Okay, this gives 2.6 millimeter. Now we go for the corrected reading, that is CR. CR is equal to, since the zero error is negative, therefore the correction should be positive. That is 2.6 plus 0.04. So that gives 2.64 millimeter. So 2.64 millimeter, from the given options, option B is the correct one. Now next question. A screw gauge, it has a pitch of 0.5 mm and 50 divisions on its circular scale. So when measuring a wire, the main scale shows 1 mm and the circular scale shows 28 divisions. So if the screw gauge has a zero error of minus 0.03 mm, so what is the correct diameter? So here for least count, okay, the pitch is 0.5 and the number of head scale divisions, that is 50. Therefore the least count is 0.01 millimeter. Now we go for the total reading calculation. Total reading is equal to the main scale reading, that is 1, and the circular scale division, that is coinciding with the main scale line, that is reference line, that is 28 into the least count 0.01. So this gives you 1.28 millimeter. Now the zero error is negative, therefore the correction should be positive. Therefore the corrected reading is 1.28 mm plus 0.03. So therefore the final answer will be 1.31 millimeter. The next question. In a screw gauge, the pitch is 0.5 mm and the number of circular scale divisions, that is 100. Therefore the least count for the given screw gauge, that is 0.5 divided by 100, that is 0.005 millimeter. The circular scale reading is 70 and the main scale reading is 1.5, and there is a zero error of 0.02 mm, that is positive. Calculate the correct diameter. So here also we go for the total reading calculation first, that is total reading is equal to MSR. So MSR is 1.5 and HCD, so here it is 70. Now we go for the total reading calculation, that is TR is equal to MSR, that is 1.5 plus HCD, that is 70, and the least count, it is 0.005 millimeter. Therefore 1.5 plus 0.35, therefore 0.35, okay, that is 1.85 is the total reading in millimeters. Now we have to go for the corrected reading because the zero error of the given screw gauge is plus 0.02 millimeter. Therefore the corrected reading, that is 1.85 minus 0.02, that is the correction should be negative. So in that case the final answer will be 1.83 millimeter. Next question, a screw gauge with 50 circular scale divisions and a pitch of 0.5 mm is used. When the two jaws are in contact, the 48th division coincides with the main scale line and the zero of the main scale is slightly shifted forward. If the main scale reads 1 mm and 30th circular scale division coincides with the main scale line, that is the reference line during the measurement, what is the corrected thickness? So here, the first line, it gives the pitch value, that is 0.5 mm, and the number of the circular scale divisions or the head scale divisions. Therefore, we can calculate the least count. Least count is equal to pitch, that is 0.5, divided by the number of circular scale divisions, that is 50. Okay, this gives 0.01 millimeter. When the two jaws are in contact, the 48th division coincides with the main scale line and the zero of the main scale is slightly shifted forward. That means the screw gauge has a positive zero error, and we calculate the positive zero error, that is plus ZE, that is equal to the HCD, that is 48, into the least count 0.01. This gives 0.48 mm, and it should be positive, that is plus sign. That is, we need to put plus for 0.48. Now we go for the total reading calculation. So for total reading calculation, we need the main scale reading, that is 1 mm, and the HCD is 30. Okay, therefore the total reading, that is TR, that is equal to MSR, that is 1 mm, plus HCD, that is 30, into the least count 0.01. This gives 1 plus 0.3, that is equal to 1.3. Now we go for the correction, that is the corrected reading is equal to 1.3 minus 0.48. Since the zero error is positive, therefore the correction should be negative. It is minus 0.48. This gives 0.82 millimeter. So this is the final reading after correction. Therefore, from the given option, the C is the correct option. So with this, we have completed the screw gauge series, and we will start one more new series. So in that series, we will discuss the mathematical concepts that are useful for physics. So before entering the actual physics topics.